Rationalising the denominator of a fraction is important because we don't want to leave an irrational denominator because it's not a very nice thing to have. So where possible, we try and what's called rationalise the denominator. Now, the difference between a rational number and an irrational number is a rational number can be written as either a finite number of decimal places or one that repeats, or alternatively, it could be defined as a fraction such that a and b are both integers with no common divisor. An irrational number then is something that doesn't meet that criteria. So things that are irrational, things like pi, okay, it doesn't repeat, famously doesn't repeat its decimals. Any surds, which aren't whole numbers, they are irrational numbers, cube roots, fourth roots, fifth roots, and so on. E, something that you'll meet a bit later on in this course, is also an irrational number, and there are many others that pop up in mathematics as well. So it's important that we have fractions such that the bottom is rational where we can, and the top can be rational or irrational. So for example, let's have a look at something like 1 over the square root of 3. This currently has an irrational denominator, so what we're going to need to do is somehow change this fraction so that the fraction itself doesn't change value, but so that the denominator becomes a rational number. So the trick we do here is we multiply this fraction by the number 1, but I'm going to write the number 1 in a very special way, and in this case I'm going to write it as the square root of 3 divided by the square root of 3. So because I'm multiplying this fraction by another fraction such that the top is the same as the bottom, I'm just multiplying it by the number 1. So I'm not actually changing the fraction, and that's important, because if I've changed the fraction, I've changed the number, and that's no good. And now I can just evaluate the top. So 1 times root 3, well, that's just root 3, and the denominator is root 3 times root 3. Well, by definition, that is just going to be 3, because I've just squared the square root of 3. Another way to look at that is this is 3 to the half. I'm timesing it by 3 to the half, and by my laws of indices, I can state, well, therefore, that is 3 to the half plus a half, which is 3 to the 1, which is 3. So, therefore, this fraction here, 1 on root 3, is exactly the same as this fraction here, root 3 on 3, and this is how we would leave it. Okay, this is much nicer than this, because this has a nice rational number as its denominator. More complicated examples are ones where we have the sum on the bottom of a rational plus an irrational. Specifically, we just look at the square roots in these cases. So there's a nice little trick here that we can use to get rid of the irrational number on the bottom, and that is to times it by 3 minus the square root of 2. Actually a very clever technique, because in multiplying this by this, we're going to end up with 3 times 3, which is rational, minus root 2 times root 2, which would be rational. 3 times root 2 is irrational, but we would subtract the 3 times root 2, which is also irrational, but they would cancel out. And therefore, we're left with a nice rational number on the bottom. So we're going to have 3 minus root 2 on the top as well, just because I want to times this fraction by the number 1. I don't want to change the fraction. And the top is therefore going to be 1 times 3 minus root 2, which is 3 minus root 2. And the bottom, I'm going to write this out in full, is going to be 3 times 3, which is 9, plus 3 root 2, minus 3 root 2, and then we're going to have minus root 2 squared, which is minus 2. And we can see that the nice part of this is that the two irrational parts on the denominator cancel out, and we're left with a fraction which just has a nice rational denominator. There we go. 3 minus root 2 on 7. So these two numbers are exactly the same number, but this one has a rational denominator. We could then split that up if you wanted to, say 3/7 minus root 2 on 7. This is exactly the same. Don't be tempted. Do not do this. It is not 1 on 3 plus 1 on root 2. That is bad maths. Do not do that. You can split a top up by the bottom, but you cannot split the bottom up by the top. Okay. That's because of something called the distributive property. All right, one more final example then, which is a little bit more complicated, but still the same principles. We've got 2 plus root 5 on the top and 3 minus 2 root 5 on the bottom. So I'm going to multiply this by the number 1, which I'm going to write as 3 plus 2 root 5 over 3 plus 2 root 5. Notice what I'm doing here is I'm just keeping the number exactly the same as the denominator was in the fraction, but I'm changing the sign of the surd. Okay, changing the sign of the surd. One could argue this is something called a conjugate. At the top then, we're going to get 3 times 2, which is 6, plus 4 root 5, plus 3 root 5, and then we've got 2 root 5 times root 5, which is 2 times 5, which is 10. And then we're going to divide that by the product of my two denominators, which is going to be 3 times 3, which is 9. The irrational parts cancel out. You could write them in, but you don't have to. And then I've got 2 root 5 times 2 root 5. Well, that is going to be 4 times 5, which is 20. So it's going to be minus 20. Okay, so there's my denominator, and I can simplify that now to give me negative 6 plus 10 is 16, plus, that should be a 3, there we go, 7 root 5, all over 11. Okay, and I've brought the negative out because 9 minus 20 is minus 11, but I've just brought that out outside the fraction, just rather than having a negative denominator. Okay, so this fraction here, which has an irrational denominator, is exactly the same as this fraction here, which now has a nice rational denominator. Thanks.